Hey, what's up, everybody? This is Titan from Titans of CNC, and today I'm going to teach you how to program the Titan 3M. So first, we programmed the Titan 1M. It was a rectangle. We programmed the Titan 2M. It was a rectangle. Now we're going to a round part with the 3M, and we're going to actually add in a O-ring groove. Okay, so the cool things is we're gonna face it, we're gonna mill it, we're gonna add threads just like we did on the other two parts. So we're learning through repetition. The material size is exactly the same at 1x2 rectangle bar stock 6061 aluminum. And we're gonna add in some cool techniques. We're gonna make it happen right now. Okay, so let's go for it. So let's go up here, model. Drop down the cam. First thing we're going to do is we're going to set the job up. Boom. All right. So now I'm going to come over here. I'm going to actually say model orientation is Z and X. I'm going to hit Z right here. Boom. It already puts it in position, my work coordinates. But, I'm going to keep it with upper left. All right, so parts 1, 2, and 3 we went upper left because we were running standard hard jaws in a single vise, and the back jaw was the hard jaw. And then we had the stop on the left side, right? So then we were going upper left. Okay, so let's just make that happen. And the way we're going to do that is we're going to go back down here. We're going to say model box point. And we're simply going to hit this point right here. Everything is in position. Everything looks perfect. I can see it down inside the material. Okay, so let's go get our bar stock. Hit this guy right here. I'm going to say add to all sides. I'm going to go 0.050, 0.050, 0.025, 0.025. Just tabbing right through, and then I'm going to come 0.230 negative 0.020 right there. I'm going to double check it here. 1x2 cut 2.05. I'm going to flip it around. I'm going to look at it. You know what? It looks like 20 thousandths. Looks like 230. Looks like 25, 25. A little bit more here. 50 and 50. I think we're good. All right. So let's say OK. All right, now we're ready to program. So we're going to come up here. First thing we're going to do is we're going to face the top. So we're going to go face. We're going to go get our tool. Come into building blocks. Grab that Kennametal face mill. Boom. All right. Now, I'm being pretty gentle with my programming because a lot of people who are learning have machines that are 4,000 RPMs or less. So I'm going to keep this at 4,000. Boom. I'm going to tab through, and then I'm just going to go 20 inches per minute. I'm going to drop down here. I'm going to go feed rate. I'm going to actually go lead in 20, 20. I'm going to actually come over here. I'm just going to keep it 20, 20. And none of this is even actually going to matter in the long run, but I did it anyway. So right there, I can see that it already knows my bar stock, my material. So I'm going to go move on. Model top on the clearance site, model top, model top, model top. Everything looks good. We're zeroed out here on the model top. That means that the face mill is going to come right across that surface. So that looks good. All right, so the direction of pass, I'm going to put 180. And the reason I'm putting 180 is because a lot of times I might run two parts in a vise or whatever. And I like to start on the left side. It's just my thing. I like to go left to right if possible. And I'm going to go pass extension. I'm actually going to go 1.5, which will actually take the center of the tool way out over here. So the edge of it passes off the material so we don't leave any lines on the material. All right. So that looks beautiful. That looks beautiful. Everything looks great. Over here, I actually don't care about this, and I don't care about that because I don't need to ramp in because I'm dropping down outside of material. Okay, so I'm going to hit this bad boy right here. Boom. Ooh, it looks good. Okay, so tool 1 is done. All right, so I'm gonna actually come up and we're going to rough the part with a 1/2 inch end mill. Make sure that you guys have your prints. Make sure that you have your setup sheets that you downloaded from related files right next to this building block in the Academy. Okay, so tool 2 is a 1/2 inch end mill. We're going to go to adaptive. So we're going to rough everything. We're going to come on here. We're going to say select tool. I'm going to go to building blocks. I'm going to actually drop down. I'm going to say 1/2 inch. Say OK. I'm going to leave it at 4,000 RPMs. I'm going to actually slow it down like 20. Say 20, 20. Here on a ramp, I'm just going to go 5. I'm going to go, I'll go 50 here on the plunge. That looks good. Boom. I'm going to come up here. It knows my material. Rest machining, because we already faced the top. I'm going to leave it alone. All right, now everything automatically looks good right here. Bottom, I'll actually come down over here and I will say negative 0.020, which drops that down just a hair because I want to like overtake it. All right, so I'm going to come up here. Boom. I'm going to say optimal load. I'm just going to go gentle. I'm going to say 75. Direction is climb cutting. I'm going to say maximum step down. That is fine. That is fine. That is fine. I'm going to say 0.010 over here. That is fine. As far as stock to leave. I'm going to come up here. I'm going to drop down. Boom, boom, boom. I'll put 100 here, which is faster than 20. And that's the movement when it's not engaged into a feed rate into the material. All right. So basically when it machines into the material and it comes out of the material, then it moves at 100 instead of 20. Then it goes back in at 20, back into the material. Transitions, looks good, looks good. Over here, because I have a pocket, actually, you know what? Let me go look over here and make sure that I get the pocket. See that machine cavities right there? I'm going to click it, and that's going to tell my tool to make sure that I'm down in that cavity. All right. So now I'm going to come back. I'm going to drop down. I'm going to say helical because I want a helical into that material right there. And I'm going to keep it nice and light. I'll go 5 degrees. All right, and I'm just going to come through. I'm going to come through. Boom, boom, boom. Everything looks good. So when we look at this pocket, we understand that a 1/2 inch end mill is about that big, right? So this is 1.125. And if you took a 1/2 inch and a 1/2 inch, that equals an inch. It basically leaves just a little nub right here that's 125, right? So you just have a little bit of extra material right here. So when it drops down, I know it's just gonna make like one cut after that, okay? So this all looks good. So I'm gonna say okay. Adaptive is calculating. I'm gonna look at it. I can see that the tool comes down outside the material. Comes in, does its thing, comes over, ramps down, boom, 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 boom. And just like I said, then it just stepped in, went around, boom. Looks great. Okay, so next thing we're going to do is we're going to use the same tool and we're going to actually finish the cavity and finish the outside. Okay, so let's go and do that. So we're going to come over here to 2D. I'm going to say 2D contour. I'm going to go get my tool. I'm going to say I want the same tool. So I just grab that guy. I say okay. Boom, boom, boom. I'm going to do the same speeds and feeds. I'm just going to go 20. I'm going to come down here. I'm going to say 20, 20. I'm just gonna say 20 on the ramp because it doesn't matter. And over here, I'm gonna say 50. So that all looks good. I'm gonna actually come in and do let's do the pocket first. Let's do the pocket. So I'm gonna come over here, contour selection. I'm just gonna select that pocket, okay? So now I'm gonna come over here, model top, boom, boom, boom. Everything looks good. If you ever wanna like make this so that yours is always on model top, remember you can click here, you can right click it, you can make all default, okay? But mine is already dialed. So I'm gonna come down here, I'm just gonna say selection, boom. Get this surface, the bottom surface, that's what I want, boom. I don't know why it's got this right here, but we're gonna get rid of it, boom. I'm gonna come up here. Now I'm gonna say that I am running left side. I'm actually gonna say where for my cutter comp. That's fine. That's fine. 20 inches a minute. This is all fine. All right. So let me talk about something. So we have a 1/2 inch tool and a 1/2 inch tool, but we have a little 1/8 inch kind of island right here we have to clean up, right? I could do a pocket, but I just want it clean, right? So what I know is when I lead in, I'm gonna wipe out that island. So I don't even care, it's only 1/8 of an inch. So I'm just gonna make sure that my lead in to this finish pass wipes that out, and that'll be the quickest way to get it done, okay? So that'll be on the next tab over here. And I'll just tab, drop down over here, 90. So these are the radiuses, right? For your horizontal, you can see it right there. And then this is your lead in on the vertical. You can see it right there. This is actually your distance. So I'm just gonna make sure, I'm gonna put like 100 thousandths, right? I'll do maybe 150. And then with this and with that, we should have no issues cleaning up the center over here, okay? Because that was just like 125. Actually, you know what? Maybe I'll just do 200 because it just doesn't matter, okay? So I'm gonna tab through, boom, 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 and it looks good. So I'm gonna say okay. And look at that. So you can see that this is the center of my cutter and it travels. This is the center of my cutter. So anything in here, I know that I'm in the middle. And then actually if I zoom in, I can actually see that it drops down and then it feeds in and then feeds around and it feeds out. So because the tool actually walks out here, it actually cleans up that center. All right, makes sense? So that looks perfect to me. Now, instead of going up here and doing all this, and because I got my speeds and feeds and everything's already calculated, I'm just gonna come over here and I'm going to right click, I'm gonna duplicate, I'm gonna come up here and I'm going to right click, I'm going to edit it, okay? So I basically just took the same toolpath, I'd already made adjustments in it, so I duplicated it. Now I'm gonna go edit it, and the main thing I'm gonna do is say, hey, don't do here, do out here instead, okay? It's just a quick and dirty way to make it happen. Efficiency. So we see this guy right here. I'm gonna get rid of it. And I'm just gonna click this guy out here. I'm gonna click that guy right there. And look at this. We have our arrow, boom, going around, okay? So that looks exactly correct. So I'm nice and confident. I'm just gonna move on. Now over here, everything is gonna be exactly the same except this. So now I'm gonna actually go model bottom, and then I'm gonna say -0.010, because I just wanna overshoot it a little bit, all right? Really, what I'm doing is I'm just taking my tool past it so I can have a nice finish throughout, but you can see there's a little chamfer right there, so it really doesn't matter too much, but I think this is the smartest way to go, okay? Just be safe, go a little bit more, All right, so I'm gonna come up here. Tolerance looks good. Where everything is already in here. Boom, 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 boom. All right, so I'm gonna come over here, tab down. Everything looks awesome. This one, this 200 now, I was in here. I was going a nice distance in, but now I know I just have a little bit of material over here, so I don't need that much. So I'm actually just gonna say 0.050 just to make it more compact inside so I'm not wasting space. All right, so that looks good. I'm gonna say okay. Boom. I'm gonna look at the part. Part looks great. All right, so I can see that I drop in, lead in, go around, come out. All right, so now the top is done, the inside is done, the outside is done. So now we're going to cut this O-ring groove in, okay? So when you look at sheet 3 of 3, you can see that the O-ring groove is actually 70 thousandths. It's tiny. It's the tiniest thing that we've ever done. And we have to be very careful because we're dealing with tiny little carbide tools, okay? So the depth is 63 thousandths. It's all drawn up. It's all perfect, okay? So now we just got to cut it. So the first thing that we're going to do is we're going to actually come up. We're going to come down to 2D contour. We're going to go get a different tool now. So in the building blocks, we're going to look at our end mills and we're going to come down to a 16th flat end mill, which is 62 thousandths. All right. So when you look at 62 thousandths, like 62.5, and you take it away from 70 thousandths, which is the groove width that you see on sheet 3 of 3 of the Titan-3M, you can see that it is a difference of 7.5 thousandths, right? So 7 thousandths, 5 tenths. So we barely have any room in here, all right? So just follow me and we're gonna handle it with care, okay? So I'm gonna say okay. We're at 4,000 RPMs. And yes, we're going to go very slow. This is for teaching purposes only. And once you guys get the hang of this, you'll be able to go a lot faster and depending on the types of tools that you have. But we're gonna stick with the 7 inches a minute. I'm gonna come down here. I'm gonna say 7. I'm gonna say 7. On the ramp, I'm gonna say 7. And then I'm going to plunge at, I'll just say 10. And then we'll come up here, we'll select. So now I have a tiny tool coming in here, right? And I don't want to just drop in the material and I don't want to pre-drill it. So I'm actually going to do something and I'm going to ramp into the cut, okay? But I want to stay off the wall. So I'm going to use cutter comp. We'll get there in a second. So first thing I'm going to do is figure out where I'm going to cut, okay? So I'm going to actually do this one right here. So I'm on the inside. But remember, I can't go too far over here, so I got to stay off the side. So what we're going to do is I'm going to come up here. I'm going to say selection over here. And say 0. Now I got my face right here selected. Okay? So next thing that we're going to do, we're going to look through here. Model top, boom, boom. Everything looks perfect. Selection is perfect. I'm going to come over here. Now this is where it gets a little tricky. So I'm going to say cutter comp. And then I'm going to come down and I'm actually going to do cutter comp. I'm going to say where. I'm going to actually make this very small. I'm just going to I'm going to trick it, right? So I'm going to leave this alone. I'm going to leave all this alone. Okay. Now, when you were down here, how much material are we leaving? We're actually going to leave 3 thousandths, 3.5 thousandths, okay, on the top and bottom. It's a very small tool. It's kind of relative, right? We left, you know, 5,000s, 10,000s, 15,000s, whatever, but now we're on a small tool. We're going to keep it nice and tight, okay? So by leaving 3,000s here, it'll put my tool kind of right in the center over here, okay? So I'm going to come back up here. I'm going to actually drop down. I'm going to say, boom. Now, if I lead in and I come down and I lead out and I'm at 6,000s, I'm going to hit the material out there and possibly break my tool. So I actually don't want to lead out that much, okay? So over here, it's keeping me off the wall, okay? So over here, I'm gonna actually just come over here and I'm just gonna say 001. I'm gonna come over here and just say 0.0001 because I really just don't care, okay? Over here, I'm gonna say 0 because it doesn't matter, all right? Now, here's the trick. I'm gonna come here, I'm gonna say ramp. I'm gonna actually ramp at a decent degrees because it's gonna be ramping all the way around. So I'm just gonna hit 30 right there. My ramp clearance height, I'm gonna do nice and tight. So over here, I'm gonna actually just put 0.030 right here. Then I'm gonna drop down, boom, boom, boom. Let's see how that looks. All right, so the tool comes down right here and then it just starts walking around, boom, 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 all the way down until you get inside. All right, a little bit of wasted motion. I don't want to get it too close. And then when you can see, when you're way down here, you can actually see like it moves 1/10, like it's barely anything right there. All right, so that's what you have to be careful with, is breaking the tool. Okay, so I think that we are good on that. All right, so next thing we're gonna do is we're gonna actually duplicate this. So I'm gonna duplicate this tool right here, boom. Now I'm gonna select edit. I'm gonna do the exact same thing up here. We're gonna stick with this also, okay? So I'm gonna come over here. We're gonna select this and keep this also. I'm gonna come down here. Now I'm gonna get rid of this, okay? So this is gonna take me to the wall, okay? So now I'm gonna get rid of this. This kept me centered. I'm gonna actually get rid of it. I'm gonna come up here. I'm going to drop down, boom, boom. And where I used to be even smaller, I'm gonna say 1,000s. Then over here, I'm gonna say 0.002 thousandths. And I'm gonna get rid of ramp. Actually, I'm gonna come back over here to my plunge rate because I'm like dropping down and I just want it to be like really slow. We can adjust it later on when you get your G code. You can basically just come down like boom, like 10 thousandths above and then just speed it slowly till you're like 50 thousandths, and then you can just slow it down right into the cut so that you don't leave any big marks. All right, so we're just gonna say 3 thousandths, that'll be fine. So we're gonna pop back over here, 1 thousandths, 2 thousandths, that's our cutter count. I'm gonna say okay. I'm gonna look at it. Now you can see that it's actually like bigger right here, right? But that's because this is already cut out and this is center, all right? So it will work. All right, so that looks good. So what we're gonna do is we're gonna actually duplicate that cut right there, and we're going to come down, we're gonna duplicate it. We're gonna click it, we're gonna right click it, we're gonna edit it. We're gonna say we love it. So the only thing we're gonna change right here is actually this guy right here, okay? So I'm gonna get rid of it, and then I'm gonna click on the inside over here. Now basically, I know that everything's good, so I'm just gonna re-click it. I'm gonna double check it. See, now it's going the opposite way. So let me tell you something. The reason that we went so slow into this cut, even though we only had 3/1000s, right? We just went so slow and we babied it because this is an O-ring groove, okay? And you'll get different techniques for doing O-ring grooves. I don't want to spend a lot of time right now. I just want you guys to get it, that when you have an O-ring groove, you have to get artistic. You have to like figure out how to get in here so there's absolutely no tool lines. So when you engage the material, it doesn't vibrate, it doesn't shake. It basically just comes right into the cut and it goes around nice and slow because it's an O-ring. An O-ring is a sealing O-ring. Usually, you know, it's rubber or plastic, right? And it sits in here and it prevents moisture, water, air, whatever from getting through. And if there's like a tool mark, your O-ring could fail. So we want to make sure that it is perfect. So now that we've done the outside, the inside, now that we have all the milling done, what's next? We are going to chamfer everything. All right. So I'm going to come up here. I'm going to actually click this bad boy right here. I'm going to come down to chamfer. All right. So we have some 1032 threads. Okay. The outer diameter of the thread is actually 190. So a 1/4 inch chamfer tool will be fine. So let's come up here. Let's grab this bad boy up here. I'm gonna go building blocks. I'm gonna drop down to the bottom. I'm gonna say 1/4 inch chamfer. Say okay. We're gonna keep it at 4,000. 4,000. I'm gonna keep it at 20. I'm gonna tab through 20, 20. I'll actually put this at 50. All right, so everything looks good right there. I'm gonna actually come up. Now, what are we gonna chamfer? So we can barely see any chamfer here, right? And over here, when you look at sheet 3 of 3, it says break all sharp edges in the notes on the upper left. It says break all sharp edges 10/1000s, okay? And that 10/1000s is a 2-place decimal. So on your print center, down low, you'll see XX, which is 2 places, equals 10,000. So it's basically from 0 to 20,000s, but we'll keep it the same. All right, so we're gonna do the 10,000 chamfer right there. So I'm going to select the top part, the top surface, which is gonna bring the chamfer right to that point, and it's gonna actually create whatever chamfer I have there. So I'm gonna go this one, and I'm gonna actually do this top one here also. I'm gonna come up here, I'm gonna drop down, it's already on 0, so that's perfect. I'm gonna actually come over here. Chamfer width, we're already compensating for the width because we're on the inside, right? So I'm actually gonna hit 0 here. I'm gonna actually say chamfer tip, I'm gonna leave it at 50,000s. That's how deep it's gonna go and how off it's gonna go, right? So I'm gonna leave that alone. We are not gonna run into anything, so that's gonna be good. I'm gonna come up here. I'm gonna drop down. I'm just gonna add like a 50,000ths right there, 45, 50, right there. It really doesn't even matter. This I don't need, so I'm gonna get rid of it. Boom, boom, boom. Say okay. And look at that. Boom. All right, so you can see like it comes in, goes around, comes out, comes up, comes over, comes down, comes into this side. So that looks good, okay? But what about this guy? Let's actually do something here, okay? Let's just do a small little one. So this is 70,000. So we know that we're dealing with a 1/4 inch chamfer. And we know that when you look at the chamfer tool, whatever depth it goes, it's times 2 is the width. So if it goes 50,000s deep, then the diameter is gonna be 100. That's why I always use 45,000s or 90 included angle, right? So 45 because it's easy to calculate, okay? But how do we do this and just kiss it, just so it's not sharp? We do that by just making everything small, okay? So I'm gonna basically come up here. I'm gonna duplicate what we already did. I'm gonna come down, I'm gonna say duplicate. I'm going to click on this guy. I'm going to say edit. I'm going to say this is all good. I'm going to go back, get rid of this. Then I'm going to click this. Click this. All right. Then I notice that I'm on the wrong side. So I'm going to click this guy and then I'm going to click this guy. Hopefully that looks like it's on the right side. It's a little confusing. Then I'm going to come up here. That's perfect. This is perfect. But here's the trick. So chamfer, I'm just going to say 0.003. Okay. Now the offset, I'm just going to say 0.015. Keeping it nice and tight. Then I'm going to come over here. And when I actually drop down and I lead in, I'm going to keep it nice and tight because I'm only doing a 3000 chamfer, so it really doesn't matter. So I'm going to say 0.005, 0.005. See the safe distance right here. So make that really small. I'm going to say this one is correct. All right, now I'm going to go this one is correct. All right, that looks good. Boom, there you go, there you go. So we're looking at it as nice and tight, right? So you're coming in. You see I'm moving, boom, 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 coming in. I think it looks pretty good. All right, so that'll be nice and tight. So you'll have a 10,000 chamfer here. You'll have a 3,000 chamfer here, right? It might take a little bit to adjust. So when you're actually machining the part, we'll raise the tool up, say 10 thousandths, we'll run it, we'll see how it looks, we'll kind of measure it, then we'll drop it into position just to make sure that it's perfect. But that actually looks great right there. All right, so boom. All right, so what's the next thing that we're gonna do? We're gonna actually come in here and we're going to chamfer these holes, okay? So I'm going to come in, I'm going to say drill. I'm going to select my tool. I'm going to get the same tool right here. Boom. I'm going to click this guy. I'm going to say okay. It's already got its feed rates and everything. I'm just going to slow it down right here because we're just dropping in. Okay, this actually doesn't even matter, but I'm just going to do it. All right, and then we're going to say that's the plunge rate. So I'm going to just keep that the same. Boom, boom, boom. I'm going to come up here. I'm going to actually say, okay, hole. So I'm just going to click this guy. There you go. Boom. Put it in the center of all of them because it will select same diameter. All right. Now I'm going to come over here. That looks great. So what I'm going to do here is I'm actually going to take this guy and I'm going to say, how big do we want our chamfer to be? So it's a 190 diameter. So we want it to be about 10% bigger than the 190. So 10% of 190.190 is 19 thousandths. So that would be 209 if you added it. So it'd be 190 plus 19 thousandths, so it'd be 209. I'm actually going to say 210, we'll just round it. And right there, I'm actually gonna go half of that, which would be 105. So I'm gonna go negative 0.105. I'm gonna call it. I'm gonna come up here. I'm gonna say drilling, that's fine, it'll work perfect. Boom. We can even see the cut right there. We can see that it just was like absolutely perfect right there. Okay, so now everything is chamfered. Looks good? All right, all right. So what are we gonna do next? We're gonna actually drill these holes and then we're going to thread them. All right, so I'm gonna actually come over here and I'm going to right click this guy. I'm going to say duplicate, boom. I'm gonna get my drill, which is my 0.177 drill. So I'm gonna click over here. I'm gonna come into my building blocks. I'm gonna drop down and hit my 177 drill, which is for the roll tap or form tap. I'm gonna hit that bad boy right there. We have our speeds and feeds right here. That all looks perfect. I'm gonna go to the next one because I duplicated it. I already have everything selected, so I'm good with that. I'm gonna come down here. I'm gonna tab down. Now we're going 375, right? So I'll probably take my tab 475. All right, since I don't know your guys' leads as far as like from the tip of the tool up. So it's a 375. I'll go 475 with the tap. So this will be 575. So let's go negative 0.650, negative 0.650. Boom. And that's how deep we're gonna drill the holes. Okay, I'm just drilling it extra deep. I didn't have to go that deep, but I want to go extra deep just to give it enough room. So I'm going to come up here. I'm going to actually say peck. So I'm going to say deep hole, full retract. Boom. I'm going to say my pecking. I'm just going to say 50 thousandths for you guys, so it's just nice and gentle. Boom, boom. With other drills and stuff, I mean, you can just bang through here, right? But right now we're actually just going to take it light. And then when we machine it, I'll up the game and show you how to actually be aggressive with your drilling. Okay, so 50 thousandths, minimum's 50. That looks great. Boom. Right there. So that's our chamfer. It goes chamfer. Then you got the drill holes. Looks good. I'm just gonna take the drill holes. I'm gonna duplicate them. Say duplicate. Now I'm gonna come over here. I'm gonna right click. Boom. Now we're going to our tap. Okay. So I'm gonna come over here. I'm gonna say select tool. I'm gonna actually come to building blocks. I'm gonna actually drop down. And I'm gonna go find my tap. So it's right here, 192, boom. I'm gonna say okay. This gives me a spindle speed of 500. That's fine. All right, but we're not gonna go this deep, okay? So it's got that already. We're gonna come over here. This is all correct. All right, so now we're just gonna go negative 0.475, which is 100 thousandths deeper than the thread. And that looks good, okay? You could clearly see that this was down here and it just jumped up here, okay? So now I'm gonna come over here. Now, instead of deep drilling, I'm gonna go right hand tapping, right tapping, boom, okay? Everything looks good. I'm gonna say okay. Now that looks good. All right, so guess what? We just finished the TITAN-3M. All right, so let's actually check this thing out. So let's come up here. I'm going to right click. I'm gonna actually come down to simulate. I'm gonna simulate it. Oh, big tool. All right, I'm gonna say stock on. And I'm gonna get rid of my tool paths right here. All right, so first thing we're gonna do is we have our 3-inch face mill. So it faces across the top. Now we're going to our 1/2 inch. 1/2 inch is roughing it. Looks good, looks good. All right, all right, all right. Nice, nice. Cleaning it up, it's going to raise up, it's going to drop down, helical into the material, all the way down. Looks good. Now I just finished it. Now it's going to go on the outside, it's going to finish around the outside. All right, so now we have our little 62 thousandths end mill. See it just dropping down, dropping down, dropping down. You can actually see the material left here and see the material left here. Right? So it gets down there, comes back, drops in, cleans it up. You can see right here, like it did not See, I can come in here, I can see like it didn't hit that wall, so that's awesome. Look, success, success. All right. Now it's going down over here, finishing the other side. You see the nice big chamfer right there. You see the nice big chamfer right there, going all the way around. So it's really important to really pay attention, right? So, you know, this is a 10,000 chamfer, and look at how small this is. So this really does look like a 3,000 chamfer. I just say kissing it, just so it's not sharp, so it's not going to like catch anybody. It's not going to cut anybody. All right, so now this side looks really good. You can watch it. So being a programmer, you want to like watch all the cuts. You want to double check everything. You want to run the job higher than the material first and actually look at that number. I see so many people actually on the CNC machine and they got their hand on the button. Now we're chamfering the holes. They got their hand on the red button, but they're just looking in the machine. And I'm like, if the machine's gonna crash, you're never gonna catch it. You gotta have your hand on the red button, but you also have to keep looking where your tool's at, right? Under work. I don't like distance to go. Distance to go to what? I get it, but you gotta calculate things and what if something's wrong, right? You might not catch it. I like being in work so you actually know exactly where your tool is relative to the top surface of the part, right? So now we're drilling, so we chamfered. Now we're drilling. I'm actually gonna speed it up just to get through it. All right, so boom, drilling, drilling. I'm putting the time in. I'm double checking it, making sure it's good. Now you're tapping it. Boom, you're done. So you gotta put the time in to make sure that when you create the code, that code is safe, that it's efficient, and that it's not going to crash that machine and do a bunch of damage because you're going to be done, right? So you got to like double check everything, all right? So, woohoo, look at that, boom. Click this guy right there. You can go through, you can see all the tool paths. Oh, everything looks beautiful. We double checked everything. One thing that I'll say is, my tools are a little out of order, so I will come up here. I'm gonna actually come right in. I'm on my part right there, and I'm just gonna change my tool numbers. 1, 1, we're good. I'm gonna X out, boom. I can see tool 1, 2, 3, 4, 5, 6, boom. We're ready to go. American manufacturing, the TITAN-3M is done. Now let's go to the TITAN-4M next. Boom.